Okay, in this recording we're going to have a look at a dihybrid cross and have a look at an example of that. In a dihybrid cross we have two characteristics, dihybrid, and hybrid means a combination of two individuals. We're going to look at some creatures here, the gorgs, and there's two alleles that we're going to consider at the one time. One of them is for the green colour, and the alternative allele is for the yellow colour, or we have the dominant allele for hairiness or non-hairiness. And we're going to look at those alleles as we look through and move through these individuals and look at different combinations and what they could be. So let's start at this end, and we're going to have a look at this gorg on the end. And he's yellow, and he's going to have two alleles for colour and two alleles for hairiness. And the two alleles he has for colour must be small g and small g, otherwise he couldn't appear yellow. And the two alleles for hairiness are also going to be like that. And he is recessive for both conditions. He's a recessive condition for colour and the recessive condition for hairiness. On the other end of the scale we have an individual here who's green and hairy, and he has quite a few possibilities. He could be homozygous for both conditions, and notice again how he's got two alleles for colour and two alleles for hairiness. He could also be heterozygous for one of those characteristics, so he could be heterozygous for colour. Alternatively, he could also be heterozygous for hairiness. The last option is if he was heterozygous for both. Okay, and he has a possibility of either being homozygous, heterozygous, or a combination of in between. So that's a green hairy individual and the yellow non-hairy individual. This individual here, he is green, so he's definitely going to be have a dominant green allele, and he must have the non-hairy allele. Another option for him is that, and we work the same with this one. They must have that allele. Okay, and there's a few possibilities. Heterozygous there. Okay, and so there are possibilities for our gorg. The very first step in doing a cross is getting the gametes right, and it's really important to get these gametes perfect first. And let's have a look at our individuals here. They all have two alleles for green or for colour and two alleles for hairiness. And let's have a look at what gametes they could produce. Now, our first individual here, he could pass on a green allele or another green allele. So let's have a look. You could pass on the green allele with the hairy allele, producing a gamete with the big G, big H. He could also pass on that same green allele with the small h, and they're the possibilities he could produce. He could do the same with his other green allele, pass it on with this one or this one, but it's going to produce the same two types of gametes. The individual underneath is going to be a pretty similar scenario. This big G could go with a small h. The big G could also go with a small h, which we've already got there. The small G could go with a small h, or the small G could go with a small h. So we can see we've got two different possible types of gametes there. Now, the individual down the bottom is probably the more complex one. It's heterozygous for both traits. Let's follow it through. It could go big G with big H. It could also go big G with small h. It could go small g with big H. And it could go small g with small h. So it could actually, from that one individual, you could end up with 4 different types of gametes. Now, these gametes, I've written them all with big G first and the H second. That's pretty important when we start doing our crosses later on to get them sorted out. Now, one thing worth just pointing out quickly at this stage is that there's quite a few different options, and the G's are independent of the H's, and that's what we're calling independent assortment, and that's important to sort of understand at this stage. Okay, I'm just going to do a cross here, and I'm going to do a cross between two individuals. One individual who we'll say is heterozygous for green and is homozygous for hairy, and between another individual who we'll say is yellow, okay, must be homozygous recessive, and who is heterozygous for hairiness. And we're going to do a dihybrid cross with these two. So first thing we do is write out our gametes. Again, do a bit of practice on this if you're not too sure. First one we look at is green. Big G, big H is one possible gamete. The other possible gamete is small g, big H. For the other individual, the two possible gametes are small g, big H, or small g, small h. There's no other possibilities really. Just like in the monohybrid cross, these things translate as the gametes that are produced in meiosis down to the side here. So we write them in down the side. Okay, these gametes come to the side here. These gametes go to this side here. Okay, now it's worth taking our time here, making sure we write them out clearly and we don't muck them up. We won't use these other areas of the Punnett square at the moment, whether they're not required for this example. So let's write out the genotypes of our offspring. And our offspring are going to get a big G allele from one parent, a big G allele from another parent, a big H allele from one parent, a big H allele from the other. So these alleles from one parent and these alleles from another. So let's see how that works. So this first individual will be big G, small g, big G, small g, and big H, small h, big H, sorry. Okay. And we do the same. These alleles from this parent, these alleles from this parent. Okay. You'll probably notice that I'm writing the G's first and the H's second. And when it's heterozygous, I'm writing the dominant allele first. And that just helps me keep organised, particularly in the more complicated examples. But I think it's a really good habit to get into. Okay. And this last individual here, small g, big H, small h. Okay, and let's have a look how these guys look. I'm going to now write out the genotype and phenotype ratios. The genotype ratio, let's look at our first one here. I'm going to put a little dot down here to help me keep track of which one I'm working out. Big G, small g, big H, big H. I've got one of those individuals. The next individual I might write out is this one here. And I've got one big G, big H, heterozygous for both conditions. I have one individual is small g, big H, and I have, I'll tick them off as I go, and one individual who is small g, big H, small h. Now I've got four different individuals, four different genotypes. Four different possibilities, equal likelihood of getting either of those four genotypes. Let's see how those translate into phenotypes. Now, first one here is an individual who's green and hairy. And before I write it down, I'm just going to have a look and see how many other green and hairy individuals I have. And I've got one here, also green and hairy. So I have two individuals who are green and who are also hairy. Okay, I've got my next individual here who's going to be yellow and hairy. I've got one who's going to be yellow and hairy. And my very last individual here is going to be, another one who's going to be yellow and hairy. Ooh, he slipped through the cracks there. So this next individual, so I can actually write down here 2 yellow and hairies. So I've got 50% chance of being green and hairy and a 50% chance of being yellow and hairy. Half and half. And that's my phenotype ratio, but the phenotype being what it actually looks like.